Welcome back to College Algebra. This is the material for Section 3.6, and this will be inverse functions. So just a reminder that this is the last material that's on homework and quiz number 9, and that homework and quiz are both due on Friday, April the 3rd at 11:59 p.m. This is also the last material that's going to be on test number 3, which you all will be taking on April the 6th at 9 a.m. That Mastery Quiz 3 will open probably today if you're watching this according to the calendar, Monday, March the 30th, and it will close and be due on Sunday, April the 5th at 11:59 p.m. Remember, the Mastery Quiz will still be multiple choice and you have 3 attempts at it. The test will not be all multiple choice and you'll only have 1 attempt at it. So let's get started with section 3.6. So we'll be talking about one-to-one functions and inverse functions in this section. So first of all, we talked about, when we talked about relations and relations being functions, we talked about what was called a vertical line test. Today we're going to talk about something called a horizontal line test to determine if a graph is actually a one-to-one function. So in order for a function to have an inverse, so an inverse function we're going to be talking about today, then the function must be a one-to-one function. Essentially that means no repeated x values or y values. So every x value is paired with its own specific y value. There are no repeated y values, which you could have for a function, but not for a one-to-one function. And sometimes we abbreviate it as one-to-one, or you might see it written out as 1, 2, 1. Okay, so this also means that if it is a one-to-one function, then this function has an inverse, and this is the notation for an inverse function. It's not a reciprocal, it is literally the inverse function. So basically this means that if there's no horizontal line that touches the graph at more than one point, then we say that the function has an inverse and it is a one-to-one function. So let's look at a couple of graphs. So these two graphs, we can use this horizontal line test, and you can notice on here the graph is this red line, and I've already drawn horizontal lines through this. Notice that for this graph these horizontal lines don't intersect the graph but at one point, and this is a one-to-one function. So it has, we say it has an inverse. All right. So for this graph though, this is a very lovely function. It goes up and down like this, and as I draw at least one horizontal line, notice this one touches twice, this one touches twice, this one actually touches 3 times. This is certainly not a one-to-one function, and it does not, we'll add this in here, have an inverse. Okay, all right. So this is the kind of thing we're going to be looking at. So let's look at a graph on our own. So this graph is a very lovely function. It does pass the vertical line test for a function. However, if I come along and I try to draw a horizontal line through this graph, notice that my horizontal line, remember our horizontal line is y equals to a constant. Well, here's my horizontal line. It crosses here, 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 and here. So it crosses 4 different places. So this is not a one-to-one function. And we can also say that it does not have an inverse. Okay. All right. One more graph. I like to put this one on here because this one looks like it's flat through here, but if we could blow this up really big, it is not flat through here. So when you have a place like this, that's probably not the best place to draw your horizontal line, but I can draw a horizontal line here, and I can draw it here. It's kind of horizontal, and I can draw it down here. And none of these cross but at one point, one point, one point, one point. Like I said, this, if you could make it bigger, you would see that it doesn't touch but at one point. So this is a one-to-one function, and therefore it does have, so it has an inverse, and that's what we're going to be talking about. All right. So kind of a graphical, not that kind of graph, but a picture talk about what a one-to-one function is. We talked about the domains and the ranges of the functions. If we have a function and we have its inverse function, literally the domain of a function becomes the range of its inverse, and the range of a function becomes the domain of its inverse. So another way to say this is we swap our x values and y values when we talk about a function and its inverse. So the x values for a function become the y values for its inverse, and the y values for a function become the x values for its inverse. And we'll see how that works in just a second, but it's kind of nice, just a pictorial representation of what this means. So let's look at the graph of a function f of x, and it's just kind of this half of a parabola, and it goes up like this, and we can see some very definitive points on here. So in a table of values, I might say my function f will kind of make this work for us here. So x and f of x, or x and y. So I can see my x values are 0, and then -1, and -2. These are my x values, and to correspond to that, the y values for this particular function are 1, 2, and 5. So if I flip-flop these and I want to talk about the graph of my inverse function, what happens here is literally I'm going to flip my x's and my y's. So my y value here becomes my x value, and my x value becomes my y value. And so 2 is my x value. That corresponds to, yes, you got it, -1 is my y value. Okay, if 5 is my x value, what do you think the y value is? You got it, it is -2. So now I can graph these points. 1, 0 is here. 2, -1 is going to come down here. I'm going to need move my graph down just a little bit so we can see this. And 5, -2 is going to be over here. And as I connect these dots, then it's going to look something like this. My drawing has not improved, so that does not need to curve upwards. So we'll keep it going this direction like this. All right, and so there is the graph of my inverse function. One thing I want you to notice is this line y is equal to x is called a reflection line. So it is our identity function, y is equal to x, and any function which is an inverse is actually a reflection about this line y is equal to x. So notice here is my function. If I were to think of this as a mirror, this would be my reflection of that function, and that's my inverse function. And you'll see some of these in your homework problems when you do that. Okay. So another feature of inverse functions is if I said that f and g were inverse functions, and I used that composition that we discussed in section 3.5, and I found the composition of f and g, that would have a value of x. If I flip-flop that around and did g composed with f, so g of f, I would also get x, and this is the one time when the composition you get the same thing both directions. So if that's the case, then I would say that f and g are indeed inverses of each other. We're going to see how that works in the next problem. So what this problem tells me is I have two functions. F of x is 3/2 x minus 4, and g of x is 2x plus 8, the whole thing divided by 3. We want to find the composition of f of g, and then we want to flip-flop that and find the composition of g of f. If I get x for both of these compositions, then we say that f and g are inverses of each other. If I get anything else, then they are not inverses of each other. So we're going to start by finding f of g of x, and like I said, we did these compositions of functions. This is the same thing as f of g. We talked about this in section 3.5. So this is f of, remember I told you I'm going to substitute this function in place of g. So now I'm going to evaluate this. So this is going to be 3/2 times x minus 4, and in that parentheses I'm going to drop in 2x plus 8 all over 3. And I'm going to do some fancy simplifying here. So this is my 3 is going to divide out, and that's going to leave me with the 2x plus 8 all divided by 2 and then minus 4. I can divide 2 into both of these pieces, so think of this as 2x over 2 plus 8 over 2, still subtracting 4. 2x over 2 simplifies to x. 8 over 2 simplifies to 4, minus 4, 4 minus 4. This leaves me with x. And so that's a good start. If this hadn't been x, I could stop here and say they're not inverses. But just because I get x here doesn't mean I do not still have to do the inverse of that. So now I'm going to find g is my outside function of f of x. The other notation we used looked like this, g of f. So I'm going to have g of, and in place of f of x, the name of the function, I'm going to plug in 3/2 x minus 4. I picked the ones with fractions because I knew that y'all struggle as much with fractions as anything else. So 2 times, and in place of x, I'm going to drop in that function f. So all of this is divided by 3. So I'm going to drop in this, so 3/2 x minus 4. And I'm going to distribute 2 to both of these. So this is going to give me 6/2 x minus 8, and then plus 8 over 3. Minus 8 and plus 8 go away. 6 over 2 is 3. So 3x over 3. And this does simplify to x. And so indeed, my f of g and my g of x are the same thing. They are both x's. And so this means that f and g are inverse functions. Okay. All right. So the next thing we want to do is we want to find inverse functions. And so it's a 4-step process, but there's only really a lot of work on step number 3. But we're going to go through this same process every time. The first thing is cosmetic. If we have f of x, we're going to rewrite f of x as y. Then the second step is we're going to flip-flop the x and the y, because that's what actually makes our inverse function, just like on the graph, the problem with the graph where I flip-flop the x's and y's. The next step is to solve the function for y, and then that gives us a notation that's easy to say, okay, well, y is really f inverse of x, and then we have our inverse function. Okay. So problem number 1, step number 1 is we take the f of x and we rewrite this as y. So we have y is equal to 1/3 x minus 5. That's the first step from the previous page. The second step is we literally flip-flop the x's and the y's. So I'm going to replace y with the variable x, and I'm going to replace x with the variable y. Now the third step in this process, this is the one we actually have to do a little bit of work. So we need to solve this equation for y. So I'm going to start with x is equal to 1/3 y minus 5. I'm going to solve this for y by adding 5 to both sides, and so I'm going to have x plus 5 is equal to 1/3 y. To get y on the side by itself, I have to multiply both sides by 3, so I have 3 times x plus 5 is equal now to y. So now I've solved this equation for y. Okay, so then the last step, once again, is a cosmetic step, kind of like the first one. In place of y, I'm going to rewrite this as f inverse of x, and f inverse of x is equal to 3 times x plus 5. You could distribute this and make this 3x plus 15, or you can simply leave it as 3 times x plus 5. And we're done. Let's move on to problem number 6. Same 4 steps. The first one, f of x, we're going to rewrite this as y is equal to the cubed root of 2x minus 3. Second step is to flip-flop the x's and y's. So x is equal to the cubed root of 2y minus 3. And now I'm going to solve for y. So solving for y, I'm just going to rewrite this so that we can see what's going on. So the first thing I need to do is get rid of this cube root. And to get rid of a cube root, I raise both sides to the third power. So I have x cubed now is equal to 2y minus 3. Still, to get y by itself, I have to add 3 to both sides. So I have x cubed plus 3 is equal to 2y. And then the last step is to divide both sides by 2. And so I have collectively on the left-hand side here x cubed plus 3. And that's all going to be divided by 2. When I divide this side by 2, I just get y. And so then the fourth step, that cosmetic step, we replace this y with an f inverse, just like to write it on the left-hand side. And then my function, my inverse function, is x cubed plus 3 all over 2. And that's it. That's all there is to finding an inverse function. We're going to do a couple more of these. A couple of them are a little bit more challenging, but not too bad. All right, number 7. This is actually a restricted domain, and sometimes we have to have that restricted domain. If you remember what x plus 3 squared minus 5 looks like, just real quick kind of a sketch over here. This means I moved 3 units to the, you remember, to the left, and then down 5. So my function is over here, and it comes down and it curves and it goes back up somewhere along in here. This is not a one-to-one function. But if we restrict and only use the values of x which are greater than or equal to negative 3, that means just these values over here. So I can actually erase this part through the magic of television. This is the part of the graph where x is greater than negative 3. This is a one-to-one function. Okay, so now we can find its inverse, and so that's the reason for having this on here. It's not going to make a big deal to you guys, but just didn't want you to see it on the homework and go, what the heck is that? All right, so same 4-step process. So step number 1, we replace f of x with y. You do not have to write that restricted domain when you do this. This is just like I said, for informational purposes, we do not need to rewrite this. Okay. The second step in this process is to exchange your x's and y's. So I have x is equal to y plus 3 squared minus 5. And then the next step in this process is to solve for y. To solve for y, we'll start with this. Again, I'm just rewriting it so we can see what we're doing. So the first step would be to add 5 to both sides. So I have x plus 5 is equal to y plus 3, this quantity squared. To get rid of the squared, now I have to take the square root of both sides. My x plus 5, all of that is underneath my radical sign, and that leaves me with a y plus 3 over here on the right-hand side. To continue solving for y, I have the square root of x plus 5. Notice my square root ends after the 5, and then I'm going to subtract 3 from both sides. And so this is my new inverse function. We'll rewrite it in just a second. What I do want you to make sure you note is that I cannot collect together this 5 and this negative 3, because this 5 is underneath the square root, this 3 is outside the square root. In terms of our inverse functions, let me rewrite this actual function. So f inverse is the new function square root of x plus 5 and then minus 3. One thing I want to point out to you here is in my original function, this plus 3 was a movement, was a horizontal shift. We talked about shifts in section 3.4. This is a horizontal shift. In my inverse, that horizontal shift becomes a vertical shift outside my function. My original function, this 5 was a vertical shift. It was a shift up and down. When I get my inverse function, this 5 is going to be a shift inside, or a horizontal shift. So it's inside my function now. And that might help you a little bit in terms of making that connection to section 3.4, but it's not necessary. You can go through the process, but sometimes it's very helpful to see that. All right. Let's see if we can do another one of these. Once again, restricted domain because x squared is not a one-to-one function, but half of x squared is a one-to-one function. All right, so step one again, we call this y is equal to negative x squared minus 2. Be careful, don't lose that negative. That's going to be very important. Step two is we make this x is equal to negative y squared minus 2. Step 3, we're going to take this function and we're going to solve it for y. So I'm going to start by adding 2 to both sides. So x plus 2 is equal to negative y squared. Now I have to divide everything by negative, and so this is going to, or I'm multiplying everything by a negative. Either way is going to get me the same results. This is now negative x minus 2 is equal to a positive y squared. We'll move this down just a little bit so we can see. And now we take the square root. Now, because my x values are positive, that means that the range values for my inverse function are also going to be positive. And so rather than having to do the plus or minus, we can just do the positive square root of x minus 2 is equal to y. And so my inverse function, f inverse, just using this notation, is the positive square root of negative x minus 2. Like I said, this means that the range for my inverse is everything positive. And so we don't have to do the plus or minus. We can just do the square root. Okay. Once again, you're not going to have to state this. I'm just letting you know that. All right. Okay. I believe we have 2 more functions, and they're probably the 2 harder ones, but we're going to take this step by step, and we got this. I have confidence in you. So first step again, this is going to be y is equal to 1 minus x over 2x. Step number 2 is to flip-flop the x's and y's, and this is where things get a little bit strange and weird, and so we're going to rewrite this completely before we try to do anything else. So for step number 3, I'm going to want to solve for y. Please notice in this problem, and this is the first time we've run into this, I have 2 y's. So in order to solve for y, I'm going to go through a little bit of a process, but if you will go through this process for every single problem, it will always work. So the first thing I need to do is I'm going to multiply both sides by 2y. So when I multiply both sides by 2y, I get 2xy is equal to 1 minus y. So to get from here to here, I multiply by that denominator of 2y. Okay? And so now I have this y term here and a y term here. So now I'm going to collect all of the y's on the left-hand side. So collect y terms on the left. And that's going to give me 2xy plus y is equal to 1. Now I'm going to factor a y out of both of these terms. So y comes out, and so I have 2x plus 1 is equal to 1. And now magically I've taken 2 y's and I've condensed it into just 1 y. Now to solve for y, I divide both sides by 2x plus 1. And so y is going to be equal to 1 over 2x plus 1. And this is my inverse function. So step number 4, f inverse is 1 over 2x plus 1. And we are very happy that one is done. Okay? All right. You can pause it, go back and look at it again if you'd like to, but we're going to go ahead and move on to number 10. Last question on this particular section. So same process. I know you kind of get tired of this process, but if you do this same process each time, it will work, I promise. So y is equal to 8x minus 1 over 7 minus 5x. Got a bunch of negative signs in here, so we're going to have to be a little bit careful. Step number 2, I have x is equal to 8y minus 1 over 7 minus 5y. There's those 2 y's again. They're going to cause me problems. So coming over here for step number 3, x is equal to 8y minus 1 over 7 minus 5y. Hopefully you remember what I told you and wrote on the previous one. We're going to multiply both sides by this denominator. So I'm going to have x times 7 minus 5y is equal to 8y minus 1. I'll go ahead and distribute this. So 7x minus 5xy is equal to 8y minus 1. Same thing I did on the last problem. I'm going to collect all of my y terms on the left-hand side. This time I am going to move my non-y term over here to the right-hand side. Remember, when we move across that equal sign, we change the sign. So I still have this negative 5xy, and now I have minus 8y equals negative 1 minus 7x. Lots of negatives in here. It will be fine. Same next step, I'm going to factor out that y. So that's going to give me negative 5x minus 8 is equal to negative 1 minus 7x. To get y by itself, I'm going to divide both sides by that negative 5x minus 8. Now, because every single term up here is negative, I can also factor a negative out of the numerator. And I can factor a negative out of the denominator. And then a negative divided by negative is positive. And so this is going to be 1 plus 7x over 5x plus 8. You can rearrange these to make it look like the answer choices. Because everything's added, it doesn't matter. And so then I can call my f inverse function just this. This is step 4 again. This is going to be 1 plus 7x over 5x plus 8. If you would prefer to write this as 7x plus 1, that's fine. If you prefer to write the denominator as 8 plus 5x, that's okay too. All right, so that ends section 3.6, and that is the end of the material for test 3. So hopefully you're tuning into the WebEx sessions, or you're sending me questions, or you're just doing great without me. So hopefully homework is going well, and I hope you have a great rest of your day.